Hello everyone, and thank you for using Danomics. In this video, I'm going to review how to build a flow to perform best-in-class log data cleanup. Let's get started. So if you're not familiar with flows, remember they are a series of tools that allow you to process data in a consistent and repeatable way. The way we access flows in Danomics is we go File, New Flow. You'll give that flow a name, and you'll hit OK. In this case, I've already created this example flow that we'll be running. In this flow, we're going to start with a log input. This is the type of data that we want to process. In this case, well logs, and I select my log database. We then apply a number of tools. Remember, to add tools, we simply say new. We can start typing to get to the type of tool that we want. You can click on that and then add the tool to your flow. In this case, I've added a tool here called Fix Log Depth Problems. Fix Log Depth Problems will do things like sort your logs by depth, and this helps to eliminate some problems in subsequent flow tools and in the CPI. And it'll also fix problems with things like inconsistencies in your start, stop, and step fields. We have three tools here that are inference tools. The first is the infer porosity type. This tool evaluates, based on your curve descriptions, whether or not your porosity curves were logged in limestone, sandstone, or dolomite references. We have the infer resistivity log type, which will more clearly specify whether or not your logs are induction logs or ladder log type curves. And then finally, we have a SGRD log type inference tool, where it will determine if curves with the mnemonic GRD or similar to GRD are referring to either a guard type resistivity tool or a gamma ray tool. Here I've added a tool called null repeated log samples. What this does is this can trim flat spots off the top and base of logs. So in this case, I've selected a number of different curves using the drop-down menu here. And I'm only doing this for a subset of the curves as opposed to all the curves. And the reason why is some curves will naturally have lots of repeated values. For example, a caliper log, you would actually hope is a flat curve. But for things like gamma ray or density, this isn't the case. And so if we have flat spots due to things like tool pickup, I may want to remove that. And in this case, I'm removing it from the top and base of logs. You'll notice here that I've actually repeated this block. So in this case, I've selected the exact same curves that I did in the previous block, but now I'm acting on the entire log. This means not only the top and base, but also the middle. You'll notice that I've set my number of repeats higher here. This means I'm requiring it to be a larger flat spot before I will remove that data. That's because I want to set a higher threshold for it. So you will notice that what it'll do when you think about this is it'll trim the repeats off the top and the base using a slightly lower threshold than it will for removing repeated samples from the middle of logs. I've then added my SP curve baselining tool, which will go through and flatten out my SP, so it'll remove the SP drift that's associated with changes in your mud chemistry. So that way we'll have a nice baselined SP. And then finally, I've added this tool in here, which just removes logs where everything is null. And then finally, I end my flow with a log output. To run this, I then simply hit the play button. When I do this, it will open up a new jobs menu and it'll go through the steps of initializing, running, and then finished per normal. Okay, so now we see that this flow has finished running. So there's a couple of things that we may want to do now. For example, we may want to click on the sheet of paper icon to view the job report. This will tell us what tools have been ran, and then it'll also give us a summary printout of what actions have been taken. So for example, when have curves been renamed in this case. We'll also have a summary down at the bottom of the number of logs that were available after each processing run and how long each tool took to run. If you want to view this database, we can see that it's written out, this cleaned welcome data. We can click on this and we can of course preview this data and we can see how it's handled different operations. For example, here we can see how the SP curve has been corrected in this case. Okay, so that is how we use this. Now let's say you wanted to then use this cleaned up data in your interpretation. Well, how would you do that? Well, what you would do is you would simply open your petrophysical interpretation and you would come over here and select this new log database. And now that data is available for you to work on. Okay, and if you wanted to rerun this flow, so let's say we wanted to run this flow in a different database, what is it we would want to do? We'd want to come in here, select the database that we want to work on, and we'd probably want to give it a new output name so as not to overwrite this database that we just made. All right, so that's how easy it is to run a best-in-class log cleanup workflow in Danomics. If you have any questions about how to run this type of flow or any other flows within Danomics, please feel free to reach out to us at support@danomics.com. Thank you.